Hello students, welcome back to my channel Commerce with Vikas sir. Today we will be learning the concept of total product, average product and marginal product with the help of an examples, and this concept is very important while discussing or analyzing the law of variable proportions. Okay, so let's discuss in detail the each item, that is total product, average product, marginal product, and its relation with the help of an example or with the help of a table. See, total product is nothing, it is simply the total output produced. So TP is equivalent to Q, as Q denotes the level of output. Okay, so by total product we mean the total output of a good produced by a firm using given level of inputs and given time period. Okay, so using a particular time period, how much output we are producing using given inputs, that is simply the total product. Okay, so we may consider two inputs at labor and capital, or we may consider as x1 and x2, whatever may be. And out of these two inputs, one is variable and the other is fixed, and we can change the output only by changing the variable inputs, which may be either labor or which may be capital, depends upon which technology of production of firm is using. Anyway, let us assume that the firm uses two inputs, L and K, that is K being constant. So we are keeping capital as constant, labor as the variable. We can even use x1 and x2. Okay, and Q represents the quantity of output. So by using 5 units of labor, the firm produces 10 units of output. That is, it has uses 5 units of labor and it has produced 10 units of output, that is Q. And we can say that total product using 5 units of labor is 10. So Q, the amount of Q is equal to 10, and this is defined as total product. Okay, you can take the screenshot so that you can copy the notes later on, but I do suggest you just first listen the video carefully, then only you copy, because don't try to uh, memorize everything by rote. You have to understand the concept, because economics is very interesting if you understand the concept thoroughly. Okay, so total product is equal to Q is equal to 10. So in short, total product means total output. So Q is equal to total product. Now average product. As just discussed in that, by using 5 units of labor, we have produced 10 units of output. That is, 5 units of labor has produced 10 units of output. It means 1 unit of labor has produced 2 units of output, because 5 units 10, then 1 unit means 10 divided by 5, that is 2. That is simply the average product. So what average product means? Average product is defined as the total output per unit of a variable factor. Per unit of a variable factor. So how much unit of output a variable factor can produce, that is known as the average product. So average product is defined as the output per unit of variable factor. So how many outputs can 1 unit of variable factor can produce, that is defined as total product. If L and K are the two inputs used in the production, and Q represents the quantity of output produced, and if you assume that L is constant, then the average product will be, so if you consider average product, the average product is simply the total product divided by variable inputs, not the fixed input. So we cannot divide by total output input, we have to use variable input. So average product in general means total product divided by variable inputs. But if you take the average product of labor APL, then it will be Q by L. Instead of variable factor, we have to use L, where K is constant. And if you use the average product of capital, Q by K, then L is constant. So average product labor is output by unit of labor, and total product capital means total output by units of capital. So if the total output is divided by the number of variable units it is known as the average product. So average product is defined as the output per unit of a variable factor. So average product means total output divided by Q. So average product of labor means Q by L, and average product capital means Q by K. So now we'll move to marginal product. Okay, we'll move to marginal product. You may even take the screenshot. Now marginal product. So marginal means additional, it means extra. So if we go on increasing total product, then definitely total output would also increase. So marginal product is simply the change in total product due to change in one unit of input. If you introduce one additional unit of input, what will be the changes in the total product? That is simply the marginal product. So marginal product is the extra or additional output generated by using one additional units of input. So if by using one extra units of labor, how much output you can produce, or by using one extra unit of capital, how much extra output you can produce, that is simply the marginal product. So marginal means additional product. So marginal product means change in output divided by change in input. So marginal product means change in output divided by change in input. So change is denoted by delta. So marginal product of labor means delta TB divided by delta. Delta TP means change in total product. Delta L means change in unit of labor. Similarly, marginal product of capital means MPK, that's delta TP divided by delta K. Delta TP, change in total product, will remain same. But if you want to find the marginal product labor, and you divide by delta L, or change in labor, and you want to find the marginal product of capital, then you have to divide by delta K, and delta K is the unit of capital. So I hope you have clearly understood the concept of total product, average product, and marginal product. So total product means the total output produced during given period of time, so it is equal to Q. Average product means the total product produced by Y in unit of a variable factor, and marginal product means the increase or change in total product due to change in one unit of a variable factor. Now we need to establish the relation between total product, average product, and marginal product with the help of a table. Later on, we'll explain with the help of diagram. Now we are explaining with the help of a table or the help of a schedule. So in order to do this, we have drawn a diagram like this. See, the concept of total product, average product, and marginal product. So on the very left of the diagram, you'll have the labor expressed in unit, then total product, average product also in unit, then average product AP in units, and the marginal product in units. And we are taking only the labor as the variable factor. Okay, so we have to do this much. And now the problem is, if I scroll this, the whole part is not visible. So what I did, just, I'm sorry, T H the okay. So I hope if it is brought down here, then it will be easy. Okay, you may even take a screenshot once again. So if you take the screenshot, then it will be like this. You can take a screenshot up to this marginal product. So you can take a screenshot up to marginal product, then this much. So take the screenshot, then we are moving towards explanation. Okay, so I'm doing this much. So first, okay, this is the absolute position. So I want to reduce the zoom. Okay, so here you have labor expressed in unit, then total product expressed in unit, then average product expressed in unit, then marginal product expressed in unit. First, you have to memorize. You have to take units of labor from 0 to 10. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Don't take from where you have taken. It is assumed that. Okay, it is just the assumption. So 0 to 10. Then total product. Again, you have to memorize this point. 10. Total product is first 0, then 5, then 14, then 30, then 52, then 70, then 84, then 91, 96, then again 96, then 90. See, we have to take this figure, otherwise you will not get the desired result. So you have to memorize this point also. So we are taking total product as 0, 5, 14, 30, 52, 70, 84, 91. What we are seeing, the total product is increasing. Then it becomes 96, then again 96. It means a constant point. It is not increasing further. And after that, it is not increasing, it is decreasing. Then its total product is decreasing. Now we can calculate average product. Average product means total product divided by units of variable factor. So if 0 is divided by 0, then it is 0. 5 divided by 1, that is 5. 7 divided by 2, that is 14 divided by 2, that is 7. 30 divided by 3, 10. Likewise, 70 divided by 5, 14. 84 divided by 6, 14. 91 divided by 4, 13. Likewise, you have to divide. You have to, in order to calculate average product, you have to divide average Q divided by L. So this is Q, total product. This is Q. So this should be divided by L. L is the unit of labor. Okay. This is the average product. Then how can you find out marginal product? Marginal product means change in output due to change in one unit of input. So first, for first unit, there will be 0 marginal product. For second, and that is 7, that is second. Change in total product due to change in one unit of input. So when the output was 0, the total product was 0. When the output becomes 1, the total product becomes 5. So due to change in one unit of input, the change in total product is 5 minus 0, that is 5. So again, if we increase the output to 2, then the total product increases to 30. It increases to 14. So change in output will be 14 minus 5, that is 9. Likewise, 30 minus 14. Likewise, 52 minus 30. Then again 70 minus 52. Then again 84 minus 70. Then 91 minus 84. Then 96 minus 91. Then 96 minus 96. Then 90 minus 96. So if you do this, first you will get 0, then 5, 9, 16, 22. It is increasing, then it is decreasing. See, 18, 14, 7, 5. It is decreasing constantly. Then it is becoming 0. And after that, it becomes negative minus 6. That is, marginal product becomes negative also. Okay, up to a certain level of output, marginal product becomes positive. Then it becomes 0, and eventually it becomes negative. Okay, so from this relation, what you are seeing, so as soon as total product increases, average product also increases. Okay, so the relation between total product and average product, you see this from the table given below. It shows that with an increase in labor, the total product increases. However, at the initial stages, TP increases at increasing rate, then increases at decreasing rate. When TP reaches at its maximum, then MP is equal to 0. See, when TP is increasing, then AP is also increasing, but AP is increasing at increasing rate, that is increasing faster than increase in total product. After that, TP continues to increase, but AP, the increase in AP will be less. Then when TP becomes maximum, that is 96. After that, it is also 96. So you can say that 96 is the maximum point because it is not in going above 96. So when TP is maximum, what you are seeing, your marginal product is becoming 0. Okay, when TP decreases, the marginal product become negative. So when marginal product becomes 0, when TP becomes maximum, marginal product becomes 0. When TP starts falling, then marginal product becomes negative. Okay, so at the initial stage, TP increases at an increasing rate, then increases at decreasing. When TP increases at its maximum rate, then MP is equal to 0. Again, when TP falls, then MP is negative. Thus, the table shows the following relationship. Okay, following relationship between AP and MP. So here we see the relation between AP and MP. TP and MP. When TP increases, AP is also increasing, but when TP becomes maximum, MP becomes 0. When TP starts falling, MP becomes negative. So using this table, you'll try to find out the relation between AP and MP. So you'll be asked to write the relation between AP and MP. So when AP is rising, then MP is greater than AP. When AP is rising, see, AP is rising 5, 14, 13. MP is also rising. Sorry, when TP is so see, when TP is rising, AP is rising and MP is also rising. AP is rising at 5, 7, 10, 13. MP is also rising 5, 9, 16. But the change in MP is greater than change in MP 5, 7, 2, 5, 9, 4. 7, 10, 3, 9, 16, 7. So when TP is increasing, both AP and MP is increasing, but the rate of change in MP is greater than rate of change in AP. So when TP increases, MP is greater than AP, or when AP is rising, you can say MP is greater than AP. When AP falls, say when when AP becomes maximum, the AP becomes maximum as 14, because after 14 it is again become 14, then it's declining. So 14 is the maximum. When AP is maximum, then MP's value is also 14. So it means when AP is maximum, the value of AP and MP becomes equal. See, again I'm saying as the telling, when AP is increasing, that is when TP is increasing, both AP and MP is increasing. But when AP and MP is increasing, the rate of increase in MP is more greater than the rate of increase in AP. When AP becomes maximum, that is reaches its maximum point, then the value of AP would be would be equal to the value of MP. When TP becomes maximum, AP becomes maximum, then AP is equal to MP. Then when TP starts falling, after 14 it becomes 13, then 12, then 10. So it is decreasing by 1 unit. But after 14 it is decreasing 7, half, then the 5, then it's 0. That is, rate of fall in MP is greater than the rate of fall in AP. It means when TP is decreasing, then AP is greater than MP, or MP is less than AP. Okay. First, when AP is rising, MP is greater than AP. Okay, when AP is maximum, AP is equal to MP. But when AP starts falling, then MP is less than AP. Okay, when AP starts falling, MP is less than AP. When AP starts falling, MP is less than AP. So this is the relationship between total product, average product, and marginal product using a schedule. But I will try to explain using a diagram. Okay. So again, let's recapitulate the relation between TP, AP, and MP. So you have already understood the meaning of TP, AP, and MP. So you have to prepare a table where we have a column for labor, total product, average product, and marginal product. 0 to 10, we have to write the figures from your own memories. Then total product, you have to write from the own memories. Average product, you can calculate using the formula, and marginal product, you can use calculating the formula. When TP is increasing, then MP is also increasing. But when TP becomes maximum, MP becomes 0. When TP becomes negative, TP becomes 0. It starts declining, MP becomes negative. But if you see the relation between AP and MP, as long as AP is increasing, total product is increasing, average product and marginal product both are increasing, but the rate of increase in MP is greater than the rate of increase in AP. It means when AP is increasing, MP is greater than AP. After that, when AP becomes maximum at the point 14, then the value of MP and AP will be equal. Thereafter, AP starts falling. When AP starts falling, then the rate of decrease in AP is less than the rate of decrease in MP. It means the MP, when AP is declining, MP is less than AP. MP is less than AP. I do hope you have understood this video. This video seems uh, uh, of nearly 18 minutes, but I have tried to explain everything in detail. Hope you have understood this concept. If you understood this concept, please pass the comment, like my video, share my video, and give a thumbs up. Thank you and have a good day.